Okay, so today the mockingbird to my right and myself are going to teach you a little bit about the product rule for exponents and the quotient rule for exponents. And then we'll get on to some other topics a little bit later on. But for now, we've got to learn the product rule and how we add the exponents together. You'll notice there's some writing on here as I go through the pages. First video failed, so let's make this a little bit better this time. Okay, so first thing we need to know is some important vocabulary. If you see a number in front of a variable, that big number is called your coefficient. You need to know what I mean when I talk about coefficients, or what your math teachers mean when they talk about coefficients. The base is the number that's taken to an exponent, or the variable that's taken to an exponent. So that could be a number, maybe 3 to the 6th or 9 to the 6th, or whatever that number or that variable represents. And then your exponent is that small number that's up on top of the variable, or on top of the base. All right, so let's talk about why we add them. First, let's know this is our base. Our base is x. If the bases are the same, that allows you simply to add the numbers together. 3 plus 8 is 11, so x to the third times x to the 8th is x to the 11th power. Just like that. If you show your work just like this, you'll get a lot of these right as you go. Our base is the 2. It's the 2 to the 4th power times 2 to the 2nd power is as simple as 2 to the 4th plus 2, which is 2 to the 6th. You just add 2 plus 4. When it gets a little bit more complicated looking, again, you have to find like bases. This is the x, this is the x, and you simply add 2 plus 3. X to the 2 plus 3 is 5. This is y to the 1st power. That 1 won't be there in your textbooks or on your assignments in Google Classroom, wherever you might get them. But you have to know that a variable, a y, is y to the 1st power, or an x, or a d, or any particular variable. So y to the 1st power and y to the 4th power, the same base again. You just add the 1 plus 4 and you get 5. Pretty simple stuff once you understand it. Another great strategy is to expand it, and that helps you understand why you add them, or helps me understand. Hopefully it helps you too. So if I take x to the 3rd power and I write it x times x times x, and then I take x to the 8th power and write 8 x's, I'll notice that there's x times x times x, 11 of them there, x to the 11th power. So expanded form is a real easy way to make sure you get them right. This is 2 to the 4th power, so that's 1, 2, 3, 4 2's. That's 2 to the 2nd power, 2 squared. That's 2 more 2's. 1, 2, 3, 4, 5, 6. As simple as adding them. 2 to the 4 plus 2. Okay, you can do that with the more difficult looking ones, more complicated mathematical product problems. I've got 2 x's. And I've got 3 x's, 1, 2, 3, and that's x to the 5th power. 2 plus 3, of course, is 5. Again, this is y to the 1st power, so I would just write 1y right here if I'm going to expand this, and then this is y to the 4th power, so that's 1, 2, 3, 4 more. And of course, you wind up with 1, 2, 3, 4, 5. As simple as adding 1 plus 4. Okay? So I hope you understand why you get to just add the exponents for the product rule. The quotient rule, you subtract. And let me see if I can make that clear to you as well. In this particular fraction, I have x to the 5th power and x to the 2nd power in the denominator. So I'd say that equals x to the 3rd. And I'm going to show you on the next page exactly why, hopefully. You'll understand why. Here we've got 3 to the 5th power. Our base is 3. Our exponent is 5 in the numerator. And our base is 3. And our exponent is 3 also in the denominator. One thing I'd like to tell my students is that means you have 2 more in the numerator. So you have 3 to the 2nd power. If I had 2 more in the denominator, it might look like this. But that's for a later date. Here we've got, like I said, there's 2 x's in the top, x to the 2nd power and x to the 1st in the denominator. There's 1 more in top, and there's 5 y's on top and 3 y's on the bottom, or in the numerator and denominator, and that's 2 more in the numerator. So let's look at this. If I expand this, this is x to the 5th power, 1, 2, 3, 4, 5 in the numerator, and x squared in the denominator, 1, 2, or x to the 2nd power. Now I can cancel an x over an x, and then it will equal 1. Any number over itself, of course, equals 1. So, and a variable over itself also just simplifies to 1. So that's 1. And then another x over x also cancels out to 1, which leaves me with 1 times x times x times x in the numerator, and 1 times 1 in the denominator. So x to the 3rd over 1 equals x to the 3rd. Our rule is to simply subtract 5 minus 2. And again, if you think about it, you have 5 x's in the numerator, 2 in the denominator, 5 minus 2, because 2 of them will cancel out. Works every single time. Here I've got 2 in the numerator again for the x and 1 in the denominator, so it's 2 minus 1 for the x's. 2 minus 1, of course, is 1. I've got y to the 5th power and y to the 3rd power in the denominator, so it's 5 minus 3. Y to the 5 minus 3 is y squared. 5 minus 3, 5 minus 3 is 2. So here on my original video, I showed people the work, exactly how you should do it. I take the x to the 5th. I know I'm talking about multiplication, so I just take x to the 5 plus 3, just like I wrote there. And of course, 5 plus 3 is 8. Again, if you like the strategy of expanding it out, go ahead and do that. Here I explain that integers are super important in mathematics, especially in your algebra. So I wind up with 5 plus negative 1, because I just add for the product rule. And 5 plus negative 1 is the same thing as 5 minus 1, which of course is 4. So you have to be able to add your integers correctly, of course. Okay, our quotient rule, of course, we discussed. It's a subtraction thing, so I subtract the exponent of 5 minus the exponent of 3, and 6 is my base. 6 to the 5 minus 3, of course, is 6 squared. Same thing here, except for this time it's going to be a smaller number minus a larger number, which of course always ends up being negative. Now I haven't explained the negative exponent rule to you yet, but I will get to that. So I write it like this: x to the 4 minus 7. And 4 minus 7, of course, is negative 3. That won't look like that when we talk about our negative exponent rule, because we do not leave negative exponents in our answers in our math. But for now, I'm going to let you get away with it, because I just want you to really understand this quotient rule. Subtract the exponents. I appreciate you watching. I have already done these problems on the next pages, but I will explain them a little bit further if you need more explanation. If not, again, thanks for watching, and feel free to shut her off at this point and maybe move on to some of my other videos. Okay, again, for the product rule, the bases are the same. That allows me to add the exponents. This is 2 to the 4 plus 3, and that's as simple as 2 to the 7th power. This one, my bases are 3. I've got an exponent of 3 and an exponent of 4. 3 plus 4, of course, is also 7, just like that top one. Now here we have a coefficient of 2 and a coefficient of 4. And we have to understand this is a multiplication problem. Some kids will make the mistake of starting to think that they can add these coefficients together. The rule for the product is to add the exponents only. So in a multiplication problem, this is 2 times 4, which of course is 8. Then, when our bases are the same, then we get to add those exponents together. So 4 plus 2, and that gives us 6. And for the b, there was no b over here, but just b to the 4th here. So that's just going to remain b to the 4th. This is the same, add the exponents. For the quotient rule, it's the subtraction. There was not a 1 here on the original problem, but we have to understand there is a y there. There's y to the 1st power. If it was 5, it would be 5 to the 1st power, which is, of course, 5. So you don't have to write that 1 there. But anyway, we subtract 4 minus 1. Excuse me, 4 minus 2, because you have to be careful to look for the exact same base. They switched them around a little bit to try to mess with us, but we caught it. So it's 4 minus 2. which I wrote here, 4 minus 2, and that's x to the second power. And then it's going to be 3 minus 1, y to the 3 minus 1. Of course, that's also 2. And this one looks a little bit messy to me, but I want to see these coefficients again. This is, you do not subtract those. Coincidentally, it'll come out to 2 also, but you simplify it just like any other fraction. So take those coefficients. I like to write them off to the side. Maybe 4 over 2, 4 divided by 2 is 2. That winds up in our numerator because that would be the same as 2 over 1. So the 2 has to be in the numerator. Then we go alphabetically. I don't see any u's on top, but I see a u on the bottom. So in the denominator, I have u to the second power. All I have to do is copy that. And then I have to follow my rule. V to the first power and v to the third power. Technically, this is what it'll look like. I have not taught you this negative exponent rule, but 1 minus 3 gives me negative 2. And that's going to wind up looking like that. So v to the second power winds up in the bottom. And the easiest way to understand that at this point is to look here and see that there's a v in the top, 3 v's in the bottom, or in the denominator. That would cancel, and of course those 2 still wind up in the denominator. So hopefully you understand that. We'll get to this negative exponent rule soon. Again, thanks for watching.